Now that we have identified the relationship between a rational exponent and a root, we want to have the versatility of being able to bounce back and forth between the different representations. So starting with a rational exponent and turning it into a root is typically not super challenging. If you can identify who the rational exponent is applied to, that's who gets placed inside of the root. Going from a root to an exponent usually is an exercise in making sure that you're writing your expressions very carefully to ensure that the correct base is being raised to the correct power. So what do we mean by that? Well, example-wise, let's take a look at an example. We've got the fifth root of 13a. That fifth root is applied to both the 13 and the a, and we've established at this point that the nth root is just the fractional reciprocal power. So because this 5 is applied to the 13 and to the a, all of 13a will need raised to the fifth power. Let's contrast that to another example, 2x, the fifth root of y to the 7th. In this example, only the y to the 7th is having its fifth root taken. So when I go to write its fractional expression, its fractional exponent expression, I'm going to leave the 2x as being separate, and it's y to the 7th only who's going to get that 1/5 power. Now, we are not done. We want to make sure we write this very carefully. This 7 as a power to a power can get multiplied by the 7, or the 1/5, excuse me, and become y to the 7/5. Note carefully that there's no parentheses in my final expression anywhere. I don't want that 7/5 to apply to the x and to the 2. In this next example, we're going to have a similar situation, but this time the root is going to be in the denominator. No difference to us, and frankly, actually a little bit easier to write, because we want to represent that root as just being part of the denominator. If we want to write the expression with no fraction, we can move the divisor back into the numerator with the 2v and flip the power to being negative to show that division. This is not ideal. I'm merely showing this to you as an option. That is not the best way to do this. This would be probably where we would want to represent our answer in the most efficient way, and using some of the standard rules of exponents. All right, for our last example for this video, let's look at a fourth root. And we're going to look at the fourth root of 5xy to the third power. The presence of the parentheses should tell you that something different is happening in this example, the parentheses inside of the root. And here we have the third power for the y, the x, and the 5. So when we move the root to being another power, we're already going to have 5xy to the third power. We're going to need another power of the entire thing to represent that root. Similar to what we saw in the previous example, we can multiply these two powers together, and we get 5xy, all of this, to the 3/4 power. If you don't like this full expression being raised to the power, bring back another one of our Algebra 1 rules. That power can be used on each of the factors individually. So just a reminder, we have lots of different ways that we can write these, and we're going to establish some rules, and we're going to work with some rules in some later parts of the lesson and parts of the other videos. But we love having the versatility of being able to write these expressions in lots of different ways. We want to be very careful with our use of parentheses to ensure that the correct parts of the expression are being raised to the correct power. Sometimes it will be an entire expression raised to a fractional power. And sometimes it will be individual factors in the expression being raised to the powers. But just as we would have done if they were integer exponents, we want to engage in the same skill when they are our rational exponents.